Hi, so in a previous video what we discussed was this idea that, if you had a unit circle, oops, let's kind of draw that again. Let's say you had a unit circle, and you're traversing along the edge of the circle. Then if I get across some point and I want to know what the XY coordinates are of that point, I can nail down a lot of information about what the X and Y coordinates are going around the circle by noting that if I drop a triangle down to the origin, that the X and Y coordinates are the lengths of the sides of the triangle, or at least the absolute value will be, and the radius or the hypotenuse of these triangles will always be the radius of the circle, which is 1. And so from that and a little bit of information, if I know the x value, I could determine the y value and vice versa. If I also knew what quadrant I was in. And so it all boils down to examining triangles of different shapes and just putting them in the right quadrant. And so what we're going to do in this video is take a look at a couple of special triangles. And so we're going to scroll up here to two different particular triangles. One of them is the pi over 4, pi over 4, pi over 2, or 45 degree, 45 degree, 90 degree triangle. And the other one is the pi over 6, pi over 3, pi over 2 triangle. So these are two different right triangles. We both have hypotenuse 1 that are of some significance to us. Now, so we're going to start by taking a look at the angle on the left. So I don't know what the lengths of these sides are yet, right? I just know that two things. One, that the hypotenuse is 1, and the other one is that these two angles are the same. So this is an isosceles triangle, right? You have one angle here and then these two angles that are identical. Now, the thing about an isosceles triangle is since these angles are the same, these opposite side lengths also have to be the same. So what I know is that if I call this x and I call this y, I know this y has to be the same thing as x. So for this particular case, I know that in general that x squared plus y squared is 1, right? Because of the Pythagorean theorems. I guess it's technically 1 squared, but that's 1, right? And what I know is that x squared and y squared are the same. So that means x squared has to be a half, right? My two x squares, when I put them together, that's 1. And so x has to be, the length here has to be the square root of 1 over 2. And there's a bunch of different ways you could write this. I'm personally not like picky because I don't care that much. You can write this as 1 over square root of 2 by just evaluating the square root through. Or if you prefer rational denominators, you can multiply this by the top and bottom by the square root of 2 to get square root of 2 over 2. Either way, I don't care. So this is 1 over square root of 2. And this is 1 over square root of 2. That's what I'm going to write because it's easiest. And so whenever we have a isosceles triangle associated with the unit circle, we know that those two sides are the same, right? Whenever we have this pi over 4, pi over 4, pi over 2 triangle. Now, it's not as natural on the right what the pi over 6, pi over 3, pi over 2 relationship is like. But what I so here we're gonna have to sort of do a little bit of graphing to find out. But if I take a look at my my unit circle and I take a look at what happens when I graph an angle of pi over 6, that height right here, that height just happens to be 1/2, right? So what I know then is that my y is 1/2, right? The pi over 6 gives me an adjacent angle of 1/2, and that's of particular importance to us as we go ahead and try to work out the rest of this. So if my opposite side is 1/2, then what I know is that x squared plus y squared, which is 1/2 squared, is once again 1 squared. And so what we have is x squared is 1 minus, well, this 1.5 is going to come down, and I'm just going to square it now, so that's 1/4. So x squared is 3/4, so x is the square root of 3/4, which is fine. If you want to write it as square root of 3 over 2, that's also fine. So we have two special triangles, one that where the two sides are 1 over root 2 and the diagonal is hypotenuse is 1, when both angles are pi over 4 or 45 degrees. When one's pi over 6 degree or radians and one's pi over 3 radians, then our height is 1/2, our base is square root of 3 over 2. And so what that also tells us is that if this were the pi over 3 and this were the pi over 6, then we know that opposite the pi over 6, I'm just taking the same triangle and I'm kind of just like flipping it and rotating the other way, right? I have now that the side opposite the smaller angle is 1/2. And so my opposite side has to be square root of 3 over 2 as well. And so what that tells me is that in my first quadrant, let me, hold on, give me one moment here. Let me try to rethink this real quick. So if my angle were just pi over 6 here, then my height we saw was 1/2. And my x value would be square root of 3 over 2. If I move up to pi over 4, then both of my coordinates will be 1 over root 2, 1 over root 2. And if I move all the way up to pi over 3, then it's the same thing as the pi over 6 case, but I swap now my my x and y coordinates, right? Because I've kind of flipped the angle or the triangle that way. And so why don't we go ahead and actually plot these points just for fun. So square root of 3 over 2, over 2, 1/2, that's a point, right? Let's label it, why not? I don't know, that's very helpful. 1 over square root of 2, 1 over square root 2, that's my next point. And then finally 1/2 is my x, square root of 3 over 2 is my y. And so those are my 2 points, right? And so let's see what happens. Here I have an angle of pi over 6. If I go up to pi over 4, I hit my second point that I described there, right? And those are my x and y values. And if I go all the way up to pi over 3, then that's my third point there, right? With the x and y values switched from the pi over 6 case. So those are our special angles. Now you can just take these and reflect them to get values over here or in different quadrants. So for example, if I wanted to know what the angle would be if I were, say, at 2 pi over 3, right? If I want to know what angle would be at 2 pi over 3, I know that this angle here is pi over 3, right? This is pi all the way around. And so this angle here has to be pi over 3 so that this adds up to pi. If this is pi over 3, then the height is still root 3 over 2. My base here is 1/2. Right, that's 1/2 here, but my x value is now negative. So if I say, hey, minus 1/2 comma square root of 3 over 2, hey, that's exactly that point. And so I can do this in the other quadrants as well by just finding the appropriate triangles to match those angles, and then change the sign appropriately depending on whether or not my x and y values should be positive or negative. All right, thank you very much. If you have any questions about any of this stuff, again, email me or post in the discussion board, and I will see you in the next video.